there are two exponent properties that you will use all of the time. This is one of those. It is called the Quotient of Powers rule. And here is what it tells me. When two powers with the same base are divided, you subtract the exponents. The result stays where the larger exponent was. So let's try to make sense of this. We are going to look at the problem x to the 8th power divided by x to the 3rd power. Now let's make sure we understand why this problem matches this rule. So when I look at the rule, it tells me when two powers with the same base, do I have the same base? Yes, they are both x's, are divided. Am I dividing? Yes, I have a fraction bar. Okay, so I'm going to subtract the exponent. So let's look at my exponents. I have an 8, I have a 3. If I subtract those, that makes 5. But now we have this big question. Am I going to write x to the power 5 on the top, or am I going to write that on the bottom of my fraction? Well, the rule tells me the result stays where the larger exponent was. So where was my larger exponent? It was on the top of my fraction. So I am going to go ahead and write x to the power 5 on the top of my fraction. But now it's going to go on the bottom. Well, I don't have anything to write on the bottom, so I just put the number 1 there. Well, we all know that if I divide something by 1, it doesn't change it. So since it's just a 1 on the bottom of my fraction, I can really take that fraction away and just make my answer x to the power 5. Well, I already know what my answer is going to be, but what we really want to try and figure out is why does this make sense? So let's break it down just a little bit. If I go back to the original problem, okay, x to the 8th on top of a fraction, I know that that means x times 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 x. And x to the power 3 on the bottom means x times x times x. Well, we all know that if I divide something by itself, it's going to cancel out, right? So if I take this x and this x, they'll cross each other out. This x and this x will cross each other out. This x and this x will cross each other out. Well, now I ran out of x's on the bottom of my fraction, so I kind of have to stop crossing things out, and I'm going to look at what's left over. Well, left over, I have 1, 2, 3, 4, 5 x's on the top. That is how I got this x to the 5th, and because the bottom of my fraction ran out of stuff, that's how I got to put the 1 there. Okay, so the shortcut allows us to do this much faster than writing out a bunch of x's all the time. But this is really why it makes sense. So let's look at a couple examples. Number 1, x to the 9th divided by x to the 5th. Okay, I'm going to subtract my exponents, put my results where the larger exponent was. So 9 minus 5 is 4. I'm putting that on the top. Okay, the bottom's empty, so I put a 1 there. We all know dividing by 1 really just makes x to the 4th power. Number 2, same base, they're being divided, so I'm going to subtract. 8 minus 2 is 6, put the results where the larger exponent was. The top is empty, so I get to put a 1 there. Now this time I cannot go any further, okay, because an exponent on the bottom of a fraction, there's nothing I can really do about that. It just needs to stay down there. So this will be my final answer. When I look at number 3, 3 to the 2nd power divided by 3 to the 7th, they have the same base, so I'm going to subtract them and put the results where the larger exponent was. Top was empty, so I put a 1. Now I can actually simplify this further, because when I look at the bottom of my fraction, 3 to the 5th, I can use my calculator to figure out what that is. So I have 1 divided by, type that in, that's 243. So this would be my final answer, 1 divided by 243. Let's look at number 4, see what we can do. a to the 6th divided by b to the 2nd. I can't do anything here because these bases are not the same. So I just need to leave my answer a to the 6th divided by b to the 2nd. Now number 5. I have two different variables going on here. I have m's and I have k's. Now the great thing about these rules is that I can use them at the same time as long as I keep the same variables with each other. So as long as I keep my m's with my m's and as long as I keep my k's with my k's. So let's make our fraction bar and look at just my m's first. I have 4 on the top and only 1 on the bottom, right? If it does. So sorry that got erased there, but if again we're focusing on just our m's, I have 4 on the top. There's no exponent on the m on the bottom, so again that means 1. So I can subtract those. 4 minus 1 is 3. I put my answer where my bigger exponent was. Well, that was on the top, so I'm putting m to the power 3 on the top. When I look at just my k's, I have 8 on the top and 13 on the bottom. So again, I'm going to subtract. 13 minus 8 gives me 5. Put the answer where the bigger exponent was. Well, my bigger exponent for the k's was on the bottom, so I'm going to put my answer on the bottom. So k to the 5th. This will then be my final answer for question number 5.